Let's start by looking at how light falls upon an object that is curved or is a sphere. And to my right is the light, that's our lamp, and in this model that's our sun. Here's a sphere held up on a stick, and we can move around it and look at it from different perspectives. Whoops, there's an accidental eclipse, and my lens needs some cleaning. Now, one thing you might notice is that one half of the sphere is completely lit up in the brightness of that lamp or our model sun, and one half, the far side, is dark. No matter which way we look at it or go around it, this fact will remain constant. That will not change. Objects like that, round objects, spherical objects, lit up by a star, are going to be 50-50 bright and dark. And then if you look at the line, the terminator, that place between brightness and darkness, you can see the details come out. The mountains are easier to look at, the valleys. And again, even if we bring the camera up to the top or the side, we see the same thing, 50% bright. Here with an Earth model, the continents are moving into daytime. It's nighttime on the left, daytime on the right, 24 hours to go all the way around. And on the other side, we have the continents moving from daytime into nighttime. So even when a sphere is spinning, it's 50% dark, 50% light, always. So what if I put that sphere, take it and hold it out away from me and turn all the way around? So I'm holding it at arm's length, and now I'm just going to make one full turn. Take a look at the pattern. Can you guess what's going to start happening now? For most of you, this is probably already looking like the moon as you've been looking up at it through your whole life at different times. And so we can do the same thing with an orange sphere, getting brighter and brighter on the right side until it's all the way lit up, and now getting darker and darker with the brightness on the left side. So here's a moon model, so we can see it again with a slightly improved model. Getting brighter. This whole trip around takes around 29 days, and we spin around underneath the moon or in the center of the moon's orbit. So this is what you would see on one night, and then the next night, and then the next night, and the next night, and the next night. We're just speeding it up here. And now growing darker on the right until we get back to where we started. So this getting brighter and brighter, astronomers call that waxing. This is a waxing moon. It's growing and growing. It's not actually getting bigger, but the brightness that we can see is increasing until we get to a full moon. And where we were waxing before, this section is called waning, this half of the orbit. It's waning, it's becoming less and less bright. Waxing for the first half, and this second half is waning. Now there are four main phases that I'll be asking you to make sure to remember. So let's go over them a little bit more by name, and then we're going to start another activity. So this is a new moon. You normally don't even see it because the moon's right up there in the sky next to the sun during the day. And then that curved shape on the right we call a crescent, like a croissant kind of. It has pointy, kind of like pointy parts at the top and bottom. So that's our second phase. Our third phase is what's called a first quarter moon. It's kind of a 50-50 moon, bright on the right side, dark on the left. A first quarter moon. And then it's more than half, so astronomers call this a gibbous moon, and it's still waxing, it's still increasing, so it's a waxing gibbous. And now most people's favorite is our full moon. It's gotten as bright as it can. The sun is behind us, and we're looking out towards all of the bright side of the moon. Now it's no longer waxing, we call this waning. This would be a waning gibbous, because it's still more than 50% bright, a waning gibbous. But where we had a first quarter moon, this one is called a third quarter moon. It's 50-50. The brightness is on the left. Now I say 50-50, but half of that sphere is still being lit up. Remember, we just can't see the other part that's lit up. We're seeing more of the dark half now. And this is, again, a crescent, but we are waning. It's getting less and less, so this is a waning crescent. And that takes us almost there, back to where we started, and we're back to a new moon. So let's change up our model. Using a pizza box, here I have a squeeze ball of the Earth, but this one I shaded in. Got the North Pole in white, and here we have the sun out over there on the ladder, and there's our moon, our little moon, and our Earth in the center. Now, a question you might have is this to scale? And the answer is no. This is not how close the moon would be to the Earth. In fact, to make this really work, I should probably put that ladder about a mile away, and I should probably put that moon about where that ladder is. So I'd have to take up a lot more room. I don't have it, so we're going to make do the best we can here. And we've labeled these positions 1, 2, 3, 4, 5, 6, 7, and 8. Those strips that you see are little magnets to hold down our moon. So let's turn off the lights and try using this model, especially to predict. If you have a piece of paper, something to sketch with, that would be great. So go ahead and pause this or grab a piece of paper. So here we are. Now this is kind of random, but we call this position 1. So we see the Earth, the North Pole. We're looking down at the top of the Earth. This is the top-down view, and the sun is to the left. Now, what if we could shrink down and land on the Earth and look up at the moon? Would we see brightness, darkness, 50-50? Sketch what you think it would look like. And now let's bring our camera down, move the Earth out of the way, so as if we were standing on the Earth now. There's our sun in the distance, and do we see any of the brightness on the moon? We know it's lit up 50-50, but we cannot see the half that's bright. This is what we saw on the stick before. That is the shady side. That's the dark side of the moon. And from here you can see it. Using your imagination will be really important here to do your sketches. So let's go to number 2. We're going to pull up and make a quick sketch. What do you think the moon would look like from the Earth in this position, in this orientation? This is our top-down view. There's the North Pole. So go ahead, use your imagination. If you were on the Earth, which side would be bright, the right or the left? We're kind of on the other side of it, so this part makes this part kind of tricky. There's our view with sun, Earth, and moon. Now, let's come down to the Earth, move it out of the way. Take a look. This should look familiar to what we saw with the model on a stick. There's our crescent moon. Brightness on the right, just that sliver, that curving sliver of brightness. Okay, now third position, the moon is 50-50. There's our Earth looking down in top view. And so go ahead and make a sketch. Use your imagination. We're going to have to come around to the other side of the Earth here. So we'll be looking down. What would you expect to see? And now, let's drop the camera down, take in the sun. Sun, Earth, moon. We're looking at the shady sides. What would we see from Earth? Get that Earth out of there. Bring the camera down. And you probably are starting to see the pattern here and to sketch it out. This is first quarter moon. So on our styrofoam model, same thing, first quarter moon. So let's move on to number 4. So now the moon is a little further out than the Earth. The Earth is closer to the sun. Time to sketch or to imagine in your mind, what would that moon look like if we're actually standing on that little Earth? Take in all 3. Bring the camera around. How was your prediction? There we have our gibbous moon. It's more than 50% lit up. Just like with our styrofoam model. And that takes us to position number 5. So here the moon is the furthest away from the sun. behind the Earth even. I don't have the Earth there because it blocks out the sunlight, so we'll be taking it off as well. We would normally call that an eclipse, but we'll talk about that later. There is our Sun, Earth, Moon system. Get that Earth out of there. And you probably see this one coming. Let's swing the camera around, and I'm going to try not to let the camera shadow get in the way here, which will be a little tricky. But there is our full moon. So we went from seeing only the dark half of the moon now to seeing only the bright half. And that takes us to section 6. So now we're more than halfway around. Can you draw this? What would we see from the Earth? 50-50, more than half, less than half. Our shadow side view. It can be tricky for some students to make the connection from the top view looking down to this view from the Earth. It can take a little practice and a good deal of imagination. So our moon now looks like it's getting darker. It's still lit 50-50. It's just that we can't see as much of the lit side. So now in position 7, make an adjustment there. What would you draw? It's a little easier from this point of view to get this one. All lit, 50-50 lit. Which side would be lit, the left or the right? Okay, we just saw the big 3 now coming down, North Pole in the way, moving it out, bringing the camera down, and there we have a 50-50 moon lit up on the left side this time. Remember in position 3 it was 50-50 lit up on the other side. We can now only see half of the bright side, which is kind of like a quarter of it. So our last position before we get back is 8. Get back to home base on position 1. All right, what would you draw? We should be able to go a little quicker now. Sun, Earth, and Moon. Let's bring our point of view down and away. We were in top view, and now let's bring it down to from the Earth view. We get a curved shape, we get that crescent shape, and it is mostly dark, and the brightness this time is on the left, like it was the last 2 other positions. And that classic kind of curved crescent, I call that a fingernail moon. One just looks like that. You can just barely see that white part. So the trick here is to go from top-down view and be able to figure out what it would look like from the Earth view. And the 4 phases you really want to know are new moon, where we started out, number 1. All dark is what we see. And then first quarter moon in position 3 there at the bottom of your screen, where it's 50-50. The third one you should know is full moon, when the moon is furthest away in the system, the Earth being in between. And then third quarter moon, where it's a 50-50 moon that's bright on the left. Knowing the others is fine, but right now for next generation science standards, those are the biggies. But before we go, something else to consider. When we went through the full lunar cycle, did the moon spin? We can only see this half of the moon. This is the only part I ever showed you. I never showed you the other side. We call this the near side, and the other side the far side. And we have pictures of the far side, but nobody on Earth has ever seen the far side with their eyes looking up at night. It's always required a spacecraft or something like that. Now, some people do talk about the dark side of the moon and the light side of the moon, but that's always changing as we put the moon through the lunar cycle. It's always 50-50, as we said at the start. So the question for you, is the moon spinning? The answer may not be as simple as you think. All right, lunar scholars, thank you for watching, and hopefully this will clear up any possible misunderstandings and help you understand better. Thank you.